Hello and welcome to software architecture course. Now we will learn design patterns, basically which models the interactions, which is basically the behavior. So till now we studied design patterns which can create objects and the design patterns which can create or define the relationship between object structure. So you basically learned creation patterns and structural patterns. Now we are going to learn behavioral pattern. So what is behavioral pattern? It is basically a set of design patterns that identifies essentially the common communication, common interaction between different objects. So just like creation patterns and structure patterns, the purpose is to increase flexibility. Purpose is to reduce the coupling. So these patterns will help in increasing the flexibility in carrying out different operations. So in this lecture series we will study 5 important patterns. The first one is iterator pattern, second one is observer pattern, third one is the strategy pattern, fourth one is the visitor pattern, and fifth one is the command pattern. So iterator pattern essentially access elements of an aggregate in a sequential manner, one after another. It allows access of elements of an aggregate. Observer pattern essentially implements publish and subscribe or event listener. Strategy pattern implements different types of algorithms for a given service, and one can select the algorithm on the fly. Visitor pattern essentially separates an algorithm that is applied on an object from the object. So algorithms could be traversal and different types of access to various parts of the object. Command pattern essentially encapsulates an action. It encapsulates the parameter and the state all together. That's what is the command pattern. So let's start with iterator pattern. So what is iterator pattern and why it is required? So here the requirement is that it needs to provide a way to access the elements of an aggregate. Aggregate means set, list, tree, different types of data structure. It provides a way to access the elements of an aggregate sequentially, one after another, without exposing the underlying representation. So this aggregate object is basically an object that contains other objects for the purpose of grouping as an unit, meaning that a set is an aggregate. It contains other objects, set of elements, and it groups all these elements together. It is also called collection. An aggregate object is also called a collection. Example is a linked list or a hash table. It is also known as a cursor. The iterator is basically known as a cursor. So why do we need this iterator? It's because if I use a list, or rather if I want to use a list without knowing the internal data structure, then iterator is possibly the only way. Here I can have a list or a set or anything, but it should allow a way to traverse its elements without really exposing how list is created, how this traversal is done. So that should not be exposed to the client. It should be hidden by the iterator. Plus it should allow different types of traversal methods. It should allow multiple traversals to be in progress concurrently. So for example, one traversal could be in the forward direction, another could be on the reverse direction, and so on. They should happen concurrently. So iterator patterns essentially implements an iterator, and let us look at iterator in detail. So Iterator is basically a data structure that helps to iterate or traverse the collection, moving from the first element of the collection to its last element. Example of collections, as I said, arrays, linked list, etc. For example, I have a list of numbers, for example 4, -5, 10, 6, 8, 20, -10 and 30. Suppose I have this list. So if it is an array, then it would look like this. The first element of the array would be 4 and the index is 0. Second element is -5, index is 1, and so on. If it is a linked list, then it would look like this. There will be start, then there will be 4, -5, 10, 6, 8, and so on. So as you can see, these two representations are quite different. So let us see iterators, and I will basically explain this using two languages. One is Java, another is C. So let's look at the traversal in Java. I have got a linked list, and I get an iterator. So what I do is that I say list dot list iterator. I get an iterator, and then what happens is that I basically iterate while LTR dot has next. In that loop, basically I get the next object. So LTR dot has next, LTR dot next. So I get the next object. So this is how the iterations will continue. This is how the iterator will work. So you can observe one advantage here. The iterator really does not expose the internal structure of the list. It only returns the element for the use, and it guarantees that it's going to give you the next element. So there could be more than one iterator that can be created to a single collection, and then they can run concurrently. However, if you are to do the same thing in C in a traditional manner, then what you would do is that you will say link LTR equal to list.head. LTR is not equal to null. LTR is basically the pointer. And then object current is equal to LTR.data, and then you get the next element. So here, without the iterator, this internal structure is exposed. Like there is something called a head, there is something called data, there is something called next. These are all exposed. And first of all, there is here with this you can only traverse one way of traversal. And if the data structure of linked list is changed, then this whole code has to be modified. So let's look at the solution. Now what happens is that define an iterator that fetches one element at a time. So the solution is to basically implement the iterator. Each iterator object essentially keeps track of the position of the next element, and if there are several aggregates or several iterator variations, it is best that aggregate and the iterator classes, they realize a common interface. So the point is that if there are different variations of the aggregate, like linked list and then doubly linked list and so on, and if there are different iterator variations like forward direction, reverse direction, if these are the variations, then it would be best if these aggregate and iterator classes realize the common interface types. That's so that the methods remain the same. So the way to implement is that there is the aggregate, which is which would represent either a linked list or a set. There is the iterator, and there are concrete aggregates and concrete iterators. So what I'm trying to say is that if there are several aggregates or iterator variations, so it would be best if the aggregate classes and iterator classes realize a common interface. So these common interfaces are, in this example, is this one, aggregate, and this one. So there could be multiple concrete aggregates here, there could be multiple concrete iterators here, and a concrete aggregate will basically create an iterator. A concrete aggregate will create an iterator. This is important. And typically the iterator would be having methods like next, is done, current item. And one important method would be create iterator for this concrete aggregate. So we will continue with behavioral patterns. We learned iterator pattern. Now we are going to move to the next pattern, observer pattern. So the context here is that certain objects or certain entities need to be informed about different changes that are occurring in other parts of the system, and these changes are occurring, and then with respect to those changes certain events are getting generated. So some objects need to know those events, and through that event these objects should know that certain changes have happened. So one example is this is actually a real design example. So if you have to build, let us say, a stock update system, a real-time stock update system, so then the way it works is the stock update system publishes stock prices whenever there is a change in the stock price in the market. And there are many clients, including the ones that we see today in smartphones. So these smartphones based applications or even web based applications use this real-time stock update system. So these clients are alerted by the server whenever there is a change that occurs. So this is basically called observer pattern. Another example is from the GUI. We have already learned this architecture pattern, MVC architecture pattern. Here, let me repeat that again, what we learned at MVC. Here the button notifies the action listeners when a button is pressed. So there are different action listeners. When the button is pressed, this event is generated, and there are different views which attach themselves to the model in order to be notified. And action listeners are also attached themselves to the button in order to be notified. So both action listeners as well as the views, they are all register themselves. As soon as there is a button that's pressed, and that button press creates an event that an action listener understands, then certain action is taken that changes the model, and then model notifies to view. So this is a complex event based interaction mechanism, and this also follows the same observer pattern. Let's look at the class diagram. So here the example is basically news or some information publisher example. Here this publisher, information publisher class, has a list of subscribers. So it maintains a list of information subscriber. So I'm talking about this particular class here. And there is information list, the list of information that need to be broadcasted. Then this information publisher has a set of methods: attach a particular information subscriber or detach an information subscriber, notification mechanism, notify, add a news, or get latest news. So this is a publisher side. Then the other side is the subscriber. So subscribers, basically they have a method called update, and update has an input parameter p from information subscriber, and there are different subclasses to both publisher and subscriber. So this information publisher essentially is called the subject, which can be an abstract class or can even be an interface. Now these SMS subscriber and email subscriber are called observers. In fact, they are concrete observers. Information subscriber is an abstract observer. SMS subscriber, email subscribers are concrete observers. So by the name, I'm sure you understand what these subscribers do. Essentially, SMS subscriber would subscribe to this news and it would display SMS. Email subscriber, on the other hand, will subscribe to the news and it will send emails. So these are all different types of concrete observers. Notify method is a very important method in this case. Notify method will do the following. It will basically iterate over the list of subscribers, and it is going to update or notify these subscribers. So what's happening is that it is iterating over the list, taking each subscriber and calling update method of the subscriber. So this notify is calling the update method, which is this. So this is how the subscribers are getting notified. So look at this, that when it's updating, it is passing its own parameter, this. So it is passing self parameter, self pointer, because the subscriber might want to do something more when they are notified. For that reason, this is passed. Now what the subscriber does when this update method is called is, it basically pulls for the latest news. Here subscriber says p.get latest news. So when it is notified, then it pulls the news. So what's happening here is that it is simply, so the publisher is simply notifying it, not giving enough information, but just sending a notification, and the subscriber is basically pulling the latest news. Let's look at the interaction. So first, define an observer interface type. Typically, concrete observers can model different types of communication mechanism or communication channels, or it can even filter out different entities. It can filter out different events. So not all subscribers are interested in all events, so such kind of filterings are there at the observer level. And typically factory patterns are used to create a new observer. So the subject, as I explained in the previous slide, maintains a collection of observers. A specialized subject can model a specific type of event. So in that example, I showed that there are examples like sports event and business type event and so on. This publisher or the concrete subjects essentially implements a method for attaching and detaching the observers. So here what happens is whenever an event occurs, the subject notifies all the observers. Let us look at different implementation issues. One is many-to-many. So in that example I showed that there are two publishers, two subscribers. In reality there could be many types of events generated, many subscribers. So there will be a scenario that many subscribers may need to observe many events. So during the notification, as you see that the subject reference or the publisher reference is passed as a parameter. Recall the class diagram there. Now if the updates are very frequent, then there can be many consecutive updates, and observer can be made responsible to initiate a notify operation when it needs. So why is that required is, if there are very frequent updates, then essentially the publisher will end up sending many small events very frequently, and then that might actually cause too much of a network traffic. And in fact the publisher might also be busy in just sending those updates all the time. Instead of that, and what happens is that not many of those events are of any interest to the observer. So what happens is publisher keep pumping the information which are most of them are kind of rejected by the observers. Instead of that, a modification can be that the observer can ask the publisher for any latest news, any latest information whenever observer needs it, rather than it is getting pushed. So that's a much better way, and it basically would not clog the network. Now just before the notify is called, in this case when observer is calling or when essentially the notify method is called at the subject class, so the state of the subject should be consistent, in a sense that notification is essentially a process of sending the data. So somehow one needs to ensure that when notification is called, the subject state is in consistent state, so that the data or the information that is supposed to be there with the subject is properly updated, and the observer actually gets the correct updated data. So here is a design choice of push versus pull. Push mechanism is the subject sends the detailed information about the change to the observer, whether it uses it or not. It could be inefficient when the large number of data needs to be sent, and it is basically getting waste. In that case it becomes really inefficient. Another choice could be send only the information required by the observer. In that case the subject should know what observer requires. In fact, subject should be able to distinguish between different types of observers. For example, the SMS observer and email observer might be of two different types. In the SMS observer you might just want to send a very small information, whereas in the email you may need to send more detailed data. But in that case the subject becomes more tightly coupled to the observer. Then observer starts remembering what type of in fact the subjects start remembering what kind of observer is there, and then accordingly takes a decision. Then it as soon as such a logic is put inside the subject or the publisher, then publisher and subscriber or publisher and observer become tightly coupled. Another mechanism is pull. The subject just notifies the observer, or the publisher just notifies the observer about the change. Then the observer goes and pulls the required data. This basically is a two-step process. It's an extra overhead. So this two-step process was actually explained in that class diagram, where the publisher simply calls the observer and observer goes and gets the latest news. So it's basically it becomes a two-step process. With this we conclude. We'll continue with other behavioral patterns in the next class.